Hi, welcome back for another 7 Caillou challenge called Simple Fun, number 113, number increasing. This actually came as a request from one of my subscribers, my good friend Dodger. So let's get into it, and keep in mind in the future, if there are some challenges that you want me to cover that I haven't yet, feel free to send those my way. The task, initially a number 1 is written on a board. It is possible to do the following operations with it. You have 2 of them. You can either multiply by 3 or add 5. And your task is to determine that using these 2 operations step by step in any combination, is it possible to obtain the number n, which is our input parameter. So in other words, can you get from 1 to n using only the operations multiply by 3 or add 5? It could be all multiply by 3. It could be 5 of those and 3 add 5s. Any possible permutation, combination of that. And they have some examples here. 1 should be true because 1 is sort of the starting point, so that's a trivially true case. 2 should be false, right? Because your only 2 options from 1 are either to multiply by 3 or add 5, so there's no way to get to 2. Clearly, you can multiply 1 by 3 and get to 3, hence true. 4 is also false. Again, multiply by 3 or add 5. 5 is false for the same reason. Remember, we're starting at 1, so when you add 5, you get to 6, which you see is true. And then they give some higher value answers here. They show you how you can get to 18. You can add 5 to get to 6, and then multiply that by 3. Same for 32. You basically cube 3 to get to 27 and add 5. For 100, it's false. 101 is going to be true, and you see you just keep adding 5s, or you could think of it like you keep adding 10s. And so I hope it's clear that if you keep adding 10s, you can get to 100, and since you're starting at 1, you get 101. Input output is an integer less than or equal to 100,000, and basically you return true if n can be obtained, false otherwise. So I'm going to format mine a little bit. You know about my OCD by now if you've been with me. This is your chance to pause the video, think about it, have a go at it, and then come on back when you're ready, and I'll go into my solution. Okay, let's get rid of this. Oops, still getting used to the Mac. Okay. So let's see, how do I want to go about this? I'm going to actually use some recursion to handle this. And my strategy is going to be, I'm going to start with n, and I'm going to sort of work my way backwards to 1. And at each point, I'm going to check to see if I can get to 1 evenly with a series of divisions by 3. Remember, since I'm going backwards, I'm using the inverse operation. Our operations multiply by 3. Since I'm going the other way, I'm dividing by 3. And similarly, if I have a value of n that, well, I can say it in a way where if the 1's place value is a 1, I know I can keep taking 10 off and get down to the value 1. And similarly, if the value ends in a 6, right, because we can subtract 5, a 6 minus 5 will go down to a number ending in a 1. And from that point, we know we can subtract pairs of 5s or 10s to get to 1. So that'll be the general kind of idea here. And I'm going to make a little helper method to help me with this. Private static bool. And I'm going to say is power of 3. And this is just going to check for me if any value I want to know about is a power of 3, with the idea being that if it is a power of 3, I know I can get right to that 1 value target that the challenge specified. Because a power of 3 means, right, you have a series of the number 3, a certain count of them that you multiply all together. So let's implement this. We could say while n modulo 3 equals 0, while n is evenly divisible by 3, in other words, say n divide equals 3, which is a shorthand for saying n equals n divided by 3. And because we did this check here, we know that n is evenly divisible by 3, so we don't have to worry about truncation problems with integer division that sometimes are relevant when you're working with integers and doing division. And then the idea is we do this as many times as we can before we fall out of the while loop, and we could say return n equals to 1. That means it went through the whole series, it kept whittling this number down by dividing by 3, and it landed evenly on 1. And if it doesn't do that, then it's clearly not a power of 3. Also note that if you pass in the value 1, you actually don't get into the block of the while statement, so you just kind of pass right through. But you get n 1 equals 1, which is true, and any number to the 0 power is 1, so that is valid. So something like this should work for us to that end. So then my idea here was that I could check. I could say if n, or I'm sorry, I called it is power of 3 n, then I say return true, right? It means that it's just a bunch of multiplications by 3. And then the other idea that we could check is, remember we've got this idea where we can subtract 5. We could say if n modulo 10. Now remember, n modulo 10 means divide by 10 and take the remainder. So this is another way of getting what the value in the ones place is. So if I could say if that equals a 1, I know I can keep subtracting 10 to get back to the base value of 1. I could also return true in this case. So I mean, think of a value like 121. Just any number that ends in a 1. You can just keep subtracting 5, 5, 5, minus 5, minus 5, and take all these 10s away, and you're going to end up with 1. I don't think I need to explain that more. We kind of went over that. But that's the idea here. And if you wanted to, you could even save yourself a little work, though you don't need it. You could also say or n modulo 10 equals 6, right? Because when you subtract 5 from 6, you're going to get down to a 1. But it's not a big deal if you just do one more step in the recursion. So the recursive step then, we would say return number increasing n minus 5. We are progressing downward toward 1 by subtracting a value from n. And because we were guaranteed n as a positive integer here. And then finally, we need a base case to break out of our recursion. Otherwise, we stay in an infinite loop, right? So I want to say something like if n is less than 1, like, hey, stop processing. We could just say return false. We didn't land right at that target of 1 that we had to for the challenge. So I'll do that. And then something like this looks good. Basically, we've got our base case here to say when we're done. We've got our 2 checks. We're just saying, hey, can you get there by working with 3s, you know, dividing by 3s or multiplying by 3s, however you want to look at it. And our other check was, hey, did we reach a point where we can minus 5 and get to 1? A series of minus 5s. It might be 10 of those. We might have to subtract 5 10 times or 100 times, however many times. Can we do that? I'll eventually remove the second part, but we'll leave it for now. And then finally, we call it recursion when we invoke a function call within its own body, right? It'll keep calling number increasing. So yeah, progressing towards the base case, something like this. Let's give this a run. Good, green is good. Hit the attempt. And that looks good. I don't know what this bit about this warning is. I didn't make a variable passed, so we're gonna ignore that. We're clear for submission. I don't think, just to show you, you don't need this part. Because again, if it were a 6, it would fail this condition. You'd call number increasing n minus 5, and with that number that ends in a 6, when you minus 5 from it, it's going to end in a 1 next time. And then, so the next step through, you'll hit this case and simply return true. So we can do that again if you like. And you can keep it the old way if you liked that better and possibly wanted to save a step. I don't think it's that important. I'll go ahead and submit mine. I think I got this whittled down pretty well and formatted how I like. We'll hit submit. Now, in the comments, when Dodger requested this challenge, he said, this is it. He said there was a really concise solution here that had these list of numbers in it. And this is a really cool solution, right? It's basically saying return n is not a multiple of 5, right? If it's modulo 5 is not equal to 0, and the value passed in is not contained in this set, then you return, then it's a valid value passed in. So this seems to imply that you can get to the target from every value outside of these values combined with every multiple of 5. So I'm going to have to think about that a little bit to make sense of that, to convince myself, and there's probably a mathematical way to demonstrate that you can get to all the other values outside of what's listed here. And what I want to do with this, actually, since I didn't prepare this, I think it'd be a good exercise if we talked about this in the comments of the video, and maybe we can work this out together and convince each other that how this works. Now, you may be convinced because you see it show up in the answers, but we should be convinced because we understand it, not just because we saw it in the answers. So this was probably a good challenge to actually take some time and go through other people's solutions because there's probably a lot of variation in them. And so there's opportunity to learn something when hey, look at this, we made the Wall of Fame there. Nice. Yeah, some of those other challenges, they're really clear cut and everybody basically posts the same thing. But this is a cool one where you can learn from lots of other people. But I will leave you with that for now. Let's talk about the really cool solution here in the comments, see what we can come up with. All right, as usual, thanks for watching. I'm sorry for the long hiatus. I mentioned to Dodger I had a family emergency come up, but I'm hoping to get a lot more content coming your way. I appreciate the likes and subs. I will see you in another video. Thank you.